2,000 years ago, Roman engineers built roads so precisely, so durably, and so intelligently that sections of them survive to this day. Not as museum pieces, as actual roads still in use. The techniques they developed, without modern machinery, without computers, without any of the tools we consider essential for infrastructure, produced surfaces that outlasted the empire that built them by nearly 2 millennia. Every highway, every interstate, every modern road network on Earth owes a debt to what Roman surveyors figured out with wooden tools and mathematical discipline in the soil of the ancient world. At its peak, the Roman road network stretched an estimated 400,000 kilometers across the empire, a figure that includes both major paved highways and secondary roads, though precise totals vary among historians. It connected every major corner of an empire spanning 3 continents, linking Britain's northern frontier to the eastern Mediterranean, the Rhine to North Africa, in a system so extensive that Rome stood at the center of a vast road network connecting much of the known Roman world. Every major road was measured from a central milestone standing in the Roman Forum, making Rome the literal starting point of imperial distance and direction. But why did Rome invest so heavily in roads when no previous civilization had done so at anything approaching this scale? The answer was entirely practical and entirely military. A Roman legion, roughly 5,000 heavily armed soldiers carrying their own equipment, needed to move efficiently in all weather across terrain that could shift from alpine passes to North African plains within a single campaign. An army that moved slowly arrived too late, exhausted itself before fighting, and couldn't respond to threats on multiple frontiers simultaneously. Roads were not a luxury of Roman civilization, they were the prerequisite for Roman military reach, and that military reach underpinned everything else the empire built. The engineers who designed Roman roads understood something that seems straightforward in retrospect, but was genuinely advanced in practice: that a road's longevity depended almost entirely on what happened beneath the surface, not on top of it. Modern road builders call it the subbase. Romans called it careful layering. Before a single paving stone was laid, Roman road builders excavated the ground to a significant depth, varying by terrain and road type, removing soft soil until they reached stable ground capable of bearing sustained weight without shifting. What they built into that excavation was a carefully engineered sequence of materials, each chosen for a specific structural purpose. The bottom layer was statumen, large flat stones packed tightly to create a stable foundation, distributing weight evenly into the ground beneath. Above that came rudis, smaller stones or broken brick mixed with lime mortar, compacted into a solid mass. Then nucleus, a finer layer of gravel, sand, and lime that was pounded flat until it achieved the density of weak stone. Finally, on top came the summa crusta, the surface layer of large, precisely cut polygonal stones fitted together with considerable accuracy. The entire construction was typically cambered, slightly higher in the center than at the edges, so that rainwater drained to the sides rather than pooling on the surface and penetrating the layers beneath. The result was a road that didn't merely survive rain, frost, and the passage of armies. It actively resisted the forces that destroyed less carefully built surfaces. Roman roads endured not primarily because Romans used harder materials, but because they understood the structural reasons roads fail and engineered against those failure modes systematically. Achieving straight alignments was a surveying achievement that modern engineers still study. Roman surveyors used a tool called the groma, a cross-shaped instrument with plumb lines hanging from each arm, allowing right-angle sight lines to be established across terrain. Working with ranging poles placed on elevated ground, survey teams projected alignments across considerable distances with impressive accuracy. Aerial study of surviving road sections has confirmed their straightness across long stretches. Where terrain made straight alignment impractical, mountains too steep to cut through, valleys too wide to bridge economically, roads deviated with the minimum necessary angle before returning to the intended line as quickly as the landscape allowed. Bridges carried roads over rivers with the same structural logic. The Roman arch, with its keystone distributing compressive force outward and downward into foundations, proved remarkably durable. The Ponte Fabrizio in Rome, completed in 62 BC, still carries pedestrian traffic across the Tiber today. The Roman Bridge of Córdoba, Spain, though heavily restored across centuries, follows its original Roman foundation and alignment. These are not simply preserved ruins, they are structures whose original engineering has proven sound enough to remain in continuous use. The road network transformed the Roman Empire in ways extending far beyond military movement. Merchants moved goods across vast distances, olive oil from Spain reaching northern markets, grain from North Africa supplying Roman cities, manufactured goods circulating through a commercial network the roads made viable. Ideas and cultures traveled with the goods, architectural styles, agricultural techniques, philosophical traditions, and religious movements all spread along road corridors that connected communities previously separated by difficult terrain. When the Western Roman Empire declined through the 5th century, the roads outlasted it. Medieval communities who had no knowledge of original construction methods simply continued using them because nothing they could build themselves came close to matching the surface already beneath their feet. Medieval pilgrimage routes followed Roman roads. Trade networks followed Roman roads. The layout of many European cities reflect Roman road patterns because settlements grew at road intersections that have been continuously inhabited ever since. In Britain, roads constructed by Roman forces in the 1st and 2nd centuries AD still underlie sections of modern highways. The route from London toward Dover follows the alignment of the Roman road known as Watling Street so closely that archaeologists have identified original Roman surfaces beneath modern tarmac in places. In Italy, the Appia Way, begun in 312 BC, still extends south from Rome with original basalt paving stones intact across significant sections, still cambered after more than 2,300 years. Roman engineers built roads intended to serve an empire and inadvertently built roads that outlasted that empire, the civilizations that followed it, and continue carrying the weight of daily life today. If this gave you a new way of seeing the road beneath your feet, subscribe, because every week we trace the engineering and ideas the ancient world built into the foundations of the modern one.